In this tutorial video, we're going to talk about increasing and decreasing functions. So real quick, here are the basic definitions of increasing and decreasing. So an increasing function happens when, as you go farther to the right of a function, the y values get larger. In a picture, it would look something like this. So it should always go up to the right if it's increasing. For decreasing, it's the exact opposite. So as you move farther to the right, as your x's increase, your y values decrease. So again, in a picture, it doesn't go up to the right, it goes down to the right. So those are the basic premises for increasing and decreasing. The concepts are actually very basic. So what we're going to do next is we're going to take a look at a problem that is a graph, and we are going to select the intervals upon increasing or decreasing. And before we do that, there is one other option that we have. A function doesn't necessarily just have to be either one of these. It could also be constant. And when we talk about constant, it means just that. It's not doing either. It is a flat line. So in a picture, it's something like this. It's a horizontal line. Basically, there's no rise. It's just run. It's a slope of 0. So that's what we want to take a look at. So let's take a look at the example. All right, so here's example 1. Determine the intervals of increase, decrease, and constant. So here is our picture. Right there. Okay. So let's take this one part at a time. So just by looking at this, I see 3 distinct pieces. I see the piece on the left, that's kind of going in that upwards right direction. And by the way, whenever you're observing a graph like this or analyzing it, ignore the arrows when you're talking about increase and decrease. Those arrows don't really mean anything in terms of increasing or decreasing. It's just telling you where the function is going. So this part on the left, understand that when I trace over, it is going up to the right. And one way to remember that too is you always read a graph the same way that you read a book. It's always from left to right. So just because the arrow is right here, it doesn't mean that that's determining the increase or decrease part. From the very left point to the rightmost point of that part that I just highlighted, I am going up to the right. So this piece alone is increasing. Okay, I'm just going to put a plus sign next to it. We'll get to the intervals in just a second. So the next part that I come across is this flat line. Notice that that part will never go up to the right or down to the right. This is one of our constant areas. It has 0 slope, and it's not increasing nor decreasing, so it's constant. The last part, again, if I start from where I left off, I start from the leftmost part, I actually do go down to the right. So the arrow is in the right place for this one, but it's not always true that way. So since I'm going down to the right, this section is decreasing. So I'm going to have 3 different intervals. So the way I write my intervals for increasing is I'm going to get some parentheses set up here. And when you talk about increasing, decreasing, and constant parts of a function, you never use brackets when you are determining the intervals for this. It's always open parentheses. And the reason is because anytime you have a part like this right here where a function changes increasing, decreasing, or constant parts, nothing is actually happening there. You can't say that one point like that, when it changes, is increasing or decreasing or constant. It's just a turning point. So the part that we're looking at now, the increasing part, it looks like I go all the way up to 0 on the x-axis, and it's going to continue going on and on and on forever in the left direction. So this is going to go all the way to negative infinity. So from negative infinity to 0, my function is going up to the right. The next part is the constant part. So this, again, open parentheses, no brackets. This only lasts from 0 to 2 on the x-axis. And last but not least, decreasing starts at positive 2, and it looks like the arrow suggests that it's going forever to the right, so forever to infinity and beyond. All right, so there's our first example. Let's take a look at one more. All right, so here we go. Here's our second and last example for this. So again, we're going to find the intervals of increasing, decreasing, and constant. This function, it does look cubic, but what's important to notice is that it does give you two distinct points on here. It gives me -1, 2, and 1, -2. That's going to be really important because, well, we'll see in just a second. But if you don't have those points given to you, you may have to estimate where those points may be, and I'll show you in just a second. So let's go through this and figure out increasing, decreasing, and constant. First of all, I'm going to go ahead and eliminate the constant part because I see nowhere where the function is consistently 0 for its slope. So this is going up and down and everywhere, so there's no constant part of this function. So I'm going to go through and find the increasing part. So we are going to start from the left-hand part of my function and move to the right and see what we can find. So I start all the way to the left, which is here, and I'm going to trace my function. So right now I'm going up to the right, so this is going to be increasing. Okay. The next part that I hit, so right after I get to -1 on the x-axis, I am now going down. So from here, going down, going down, going down, and I stop going down right there. So this is a decreasing part. So I'm no longer going down. And now I'm going to have to go back up yet again from 1 on the x-axis. So from where I left off, I'm now going up to the right. So I have 2 intervals of increase and 1 of decrease. So let's go ahead and get our intervals set up. So for increasing, for the left-hand branch, this is going to go all the way from negative infinity until -1, where it no longer continues going upwards. And the branch all the way to the right that's also increasing starts at +1, and then it's going to go up forever, as the arrow indicates, to positive infinity. So when you have 2 different intervals, we're going to use our union sign or notation. So this is going to be from negative infinity to -1, union 1 to infinity. So the union just means that they're a collective whole. They're both increasing parts. And then for decreasing is pretty simple. It's just 1 interval, and it's going to it's the one that's right in between these 2 guys right up here. So this is going to be from -1 to +1. And that's it. That's as complicated right now as increasing and decreasing will get. And that will conclude this tutorial.